Hey there, it's Miss B. In this video, we are looking at the Unit 2 Lesson 4 practice problems for Illustrative Math Algebra 1. So back to our linear functions unit, we have an artist selling children's crafts. Necklaces cost $2.25 each, and bracelets cost $1.50 each. We want to select all the combinations of necklaces and bracelets that the artist could sell for exactly $12. So we want to multiply the number of necklaces by the price of a necklace and the number of bracelets by the price of a bracelet, and then add those up. I know they didn't ask us to create an equation for it, but if we did, we would say that it is 2.25 for n, the number of necklaces, and we would add up 1.50 for every bracelet, and we would want that to equal $12. So we are literally just going to add these up together and see if we can get $12 with our different combinations. So if we plugged in 5, this would be the same as doing, I'll write them underneath. It would be 2.25 times 5 plus 1.50 times 1, and we're going to add that up and see what we get. So this would be 225 times 5, that's going to give us 1125, and then when we added 150, this would be 1275. So 12.75, not gonna work because we want it to be exactly $12. So we're gonna keep going. 2 necklaces and 5 bracelets, so 2.25 times 2, and 150 times 5. So we're going to add this one up, and 225 times 2 would give me 450, and 1.50 times 5 is going to give me 750. So if I add the 450 to that, I get exactly $12. So yeah, we're going to get 12, which means this is one of our options, one of our answers, so B. And we're going to keep doing that same thing. So I might not narrate it as much, but I am going to go through and show the handwriting out for each piece and what it adds up to. So when we have 3, and when we have 3, oops, nope, 3 goes inside the parentheses, 150 over 3, and we add this up. Three, and then add the 150 times 3. Oh, this one does not work. I get that this is $11.25. So not quite gonna work. If we did, I'm not even gonna write out the next couple ones. I still have it in my calculator. I'm just gonna plug in different numbers here. So if we plug in the 4 and we plug in 2 for bracelets, this is gonna work and give us exactly $12. So this one would work as well. We would just be plugging things in the same way. 2.25 times 4 and 1.50 times 2. E, we can check these numbers here. This one is going to give us, so if we have 3 necklaces and 5 when it comes to bracelets, that is going to give us $14.25. So this is not going to work. This one gave us $12, so it did work. 6 necklaces and no bracelets, so no bracelets means a 0, and 6 necklaces, that makes $13.50. And $13.50 is not what I want, so not going to be one of our options. It's 3:30 according to my computer. So no necklaces and 8 bracelets. We can plug this one in. So no necklaces, so that would be a 0 in the first part and an 8 for the last part. And yeah, this gives me 12. So G is an option for this one. So your answers are B, D, and G. If we go to question 2, we now have a different situation. We have Diego collecting dimes and nickels in a jar, and he's collected $22.25. And then they're going to give us this equation here. They say the relationship between the numbers of dimes and nickels and then the amount of money is represented by the equation 0.10 times D plus 0.05 times N equal to 22.25. So we want to select all of the values for D and for N that could be solutions to the equation. So we're going to do the same process here and plug these numbers in. So that would be like, for this first one, we would have 0.10 times the 0 we're plugging in for D from the first one here. And then the nickels, they're saying 445. So if I'm actually labeling these, right, this is values of D and values of N, values of D and values of N, dimes and nickels, dimes and nickels. So if I plug in, I'm just going to show the work for this first one, and then I will tell you whether or not these answers actually come out to work, because once you see me plug one pair of numbers in, you don't need to see me do it 4 more times. So then this would be 0.05 times that 445, and we want to see if this works. So if we plug that into a calculator, we really just need to do the 0.05 times the 445 part, and this does make 22.25. So that one worked, and that was A. The other combinations that will work, you just need to make sure you plug them into the right place. And you can definitely use a calculator to solve these, but to plug them in. The other ones that are going to work are also going to be D and E. So B and C will not actually work for this one. But if you plug those numbers in on options D and options E, you should see that you get 22.25. So now question 3. We have volunteer drivers that are needed to bring 80 students to the championship baseball game. Drivers either have cars, which can seat 4, or vans, which can seat 6. The equation 4C plus 6V equals 80 describes the relationship between the number of cars, which is C, and the number of vans, which is V, that can transport exactly 80 students. So this is exactly 80. And they said cars was C, vans was V. And we want to select all statements that are true about the situation. Now, this is another version of the previous 2 questions. They're giving us an equation, 4C plus 6V equals 80. And they want us to plug these numbers in. But instead of giving us ordered pairs or coordinates like this one looks like, or instead of giving us numbers of things, they are telling us in sentences what that would look like. So if I converted these and I said that it was cars and vans, right, C comma V, I could translate this one into 12 comma 2, because it's 12 cars and 2 vans. And so then this one, it kind of gives it already to us 14 comma 4. And if 6 cars go and 11 vans go, there will be extra space. So extra space means that 6 and 11, when we plug those in, that answer is actually going to be bigger than 80. It's not going to be exactly 80 because extra space means this would be more than 80. That's the bell for the end of tutorial. So you heard my computer say it was 3:30. That's the bell that means it's 3:35. D is 10 cars and 8 vans is not enough to transport all the students. So that would mean that 10 comma 8 is less than 80. And then E would be basically saying if we have 20, then you could have 0. And then 8 and 8. So we're going to check through all of these. I just kind of like to translate them straight into numbers to see if they work. But we're going to do the same idea. We're going to plug them in here, plug in values for C and V. So this would be like 4 times 12 plus 6 times 2. And we want to see, is that equal to 80? Well, 12 times 4 is 48, plus 6 times 2 is 12. This is going to give us 60, which is not 80. So it doesn't work. And we're going to repeat that same process. I'm going to let you know which ones are true and are not true. And then if any of these are tricky, then I'll show you exactly what they mean. So the ones that should work are B, C, E, and F. So just not A and not D. So we can test some of these over here. And basically this would be saying 4 times 20 plus 6 times 0 is 80. And that checks out. And then 4 times 8 plus 6 times 8 equals 80. That would be 32 and 48. And that would make 80. So it would work. And then number C is the only one that talks about extra space that actually works. So let's plug those in. We want this one to be more than 80. So that means we would say 4 times 6 plus 6 times 11. This is going to be a bigger number than 80, and that's what we want to check. So 6 times 4 is 24. 6 times 11 is 66. Is that going to be greater than 80? Yeah, because this actually would add up to be 90, and 90 is greater than 80. So that makes this a true statement. Now 10 and 8 would mean that we would have 40 and 48. That would actually mean we would have more space because this would be 88. So our actual answer for D is 88, which is why it is not true, because D was saying that it would be less than 80. But yeah, if you watch me plug all of those in, this would be a really long homework video, and I don't want to do that to you. Don't want to do that to me either. So we're going to move then to question 4. And then I believe we have question 5 and 6 as review. So question 4 is still some of our linear function stuff. The drama club is printing t-shirts for its members. The printing company charges a certain amount for each shirt, plus a setup fee of $40. And there are 21 students in the drama club. So a setup fee is something you would pay once, because they're not asking you to set up every single shirt. And then we know that there are 21 students, so we know there's a certain number of people in the club. So if there's 21 students and the t-shirt order costs $187, they are asking us how much does each shirt cost. So I'm going to use T for t-shirt. Just because S sometimes looks like a 5 when I write it, or vice versa, and I don't want that to be confusing. So I am going to define a variable and then use it. I'm going to say T is the price of a t-shirt. Because I know how many I'm ordering, that's 21. The price is a little different. So 21 students are each buying a shirt, so I'm going to multiply that price by 21, and they told me there was a setup fee of $40. That should equal 187. So all we're going to do is subtract 40 from both sides because we have to keep things fair. Whatever you do to one side, you have to do to the other. So 21t is going to equal 147. And then when we divide both sides by 21, in order to get t by itself, that would leave us with t equals 7. So what that means is the shirts cost $7 each. Oops, $7 each. I just wrote a dollar sign. Okay, now this is a different company with a different equation in part B. The equation 201.50 equals F plus 650 times 21 represents the cost of printing the shirts at a second company. Now we want to find the solution to the equation and then state what it represents. So let's do the simplifying part first. So I'll write out my equation here. 201.50 equals F plus 6.50 times 21. So I'm going to multiply 21 by 650. That would give us 21 times 6.5. That is 136.5. So 201 still stays the same over here. F still stays the same. And we're just multiplying these two together, so we're not like doing something different to this side. We're just writing something that's the same. So this is plus 136.5. But now, since we're going to move the 136 away, we have to do that to both sides. So we're going to subtract 136.5 and subtract 136.5. So what that would leave us with is F is equal to 201.5 minus 136.5. That is going to give us that F is equal to 65. So now the real question is, what does that mean? Are they charging $65 for every single shirt? No, that's not the case. If we look a little bit closer at their original equation, they are giving you the 650 as the price because the 21 here is the number of students. So the F is just the setup fee. So we can say the setup fee is $65. Okay. Now for question 5, I'll put a box around this because this is my numerical answer. For question 5, we have Kieran's family having people over to watch a football game. They plan to serve sparkling water and pretzels. So more serving drinks and food. They're preparing 12 ounces of sparkling water and 3 ounces of pretzels per person. Including Kieran's family, there are 10 people at the gathering. So a bottle of water contains 22 ounces and costs $1.50. Package of pretzels contains 16 ounces and costs $2.99. We want N to represent the number of people. So N is the number of people. S represents the sparkling water. P represents the ounces of pretzels. And B is the budget. So they want to know which equation best represents Kieran's budget. Now, Kieran is not paying this per ounce. And S and P both represent ounces of sparkling water and ounces of pretzels. So if we said 150 for every ounce, I'm looking at this question. These two down here definitely appear to have prices. So this to me says $150 times every ounce of sparkling water and $2.99 for every ounce of pretzels. That is not going to work for us because that is not accurate. That would be way too much money. In the first question, they're saying $12 for the sparkling water and $3 for the pretzels. This isn't going to work either because that's the ounces. We want the budget. We want something that deals with money. So we're actually not going to use the ounces and the ounces of pretzels there either. We're going to use something more like the other ones here. And I do see the 150 and the $2.99 included in our price. Now we may have to actually calculate how many bottles of sparkling water and how many bags of pretzels we need, but it does look like our answer is going to be D. So let's check this one out and double check. If I have 10 people and 12 ounces, 10 people, I want 12 ounces of water for each person, and I want, how many for pretzels? 3 ounces of pretzels. That means for those people, that's 120 ounces total, and that is 30 ounces of pretzels total. So for the pretzels, we definitely need 2 bags, and those 2 bags cost $2.99 each, because 2 bags would give us 32 ounces. And then for our bottles of sparkling water, we would want to have 22 ounces per bottle. So you could do 120 and divide that by 22. Looks like we're going to need a little bit more than 5. We're going to need 6. And yeah, that would give us 132. So 6 bottles is going to be 132 ounces. So this one is going to be correct down at the bottom because we have the price per bottle times the number of bottles we would need, and the price per bag of pretzels times the number of bags we would need. And that is going to be the total budget. So that is the second to last question. Let's look at our very last one, which is match each feature on this of the situation with the corresponding statement and function notation. So maximum height. The maximum height I see is right here. That little point right there is the tallest point on the graph. So if I'm looking for that in function notation, that is at the input of 4, and the value is 16. They're not giving me any output values here, so we're just going to say this one is what matches with it. And actually, since this is matching, I'm going to draw lines in between them. So the maximum height is h of 4. It happens at 4 seconds. The minimum height, that looks like it happens right here. And so that looks around 1.5 seconds. So minimum height, 1.5 seconds. This one's just going to go straight across. Where the height stays the same, so staying the same, that's going to be right here where it's flat. And so that would be, that's between 7 and 8 seconds, or that value is like 6. Oh, yep, that's going to be this one down here. Height staying the same is going to be 4, because that says the value is 6 for any time between 7 and 8, so that makes sense. And then our starting height is just going to be wherever it touches the vertical axis, and that looks like it's probably 7, because halfway would be 6, and that looks like it's about 7, which turns out that that is what we have here. That is h of 0 equals 7, so that's our starting height. So that is how those all match up. And yeah, thank you for sticking with me through this assignment. There's a lot of plug in stuff for your calculator, but hopefully I helped you understand it a little bit better. And this has been Unit 2, Lesson 4 of Illustrative Math, Algebra 1.